All right, ladies and gentlemen, let's talk about dividing, a little more dividing with decimals. This time we have something terrible to talk about, and that is when there's a decimal in the divisor. That's right out here. That's the divisor. So, in order to help us understand this, I've prepared a little story for us. And this story is happy. It's about a wedding, and there's this giant wedding cake, and it looks like it's from the movie Tron or from The Matrix or something. But don't let that discourage you. I'm sure it's lovely. And what we have here is you see as a cake, one cake, and it was cut into 100 pieces or hundredths. And it looks like there's 35 hundredths left. And we see that number right here, 35 hundredths. And we're trying to divide that into 4 tenths. Now, before we start, let's just do a little reminder here, right? When we're talking about this cake, remember each column here, that number right there is 10 pieces of cake. That's 10 pieces out of 100. I'm going to change colors that show up a little better here. That's 10 pieces of cake out of 100. Now, there's a simpler way to write 10 out of 100. We can simplify that to, right, dividing them both by 10 would get us to 1/10, right? 1/10. And you might remember that each column in these hundreds grids can be thought of as 1/10. So let's think of this part right here as 1/10. And this part right here as 1/10. And this column right here as 1/10. And this one right here is not a tenth. There's only 5 hundredths in there. So I only have these 3 tenths and then plus 5 hundredths. All right, so I just wanted to show us that before we started so we can think about our division problem a little more clearly. Oh, I'm not supposed to see that. Yeah. All right, so here we go. This division problem says, how many times could I take away 4 tenths? Let's imagine there was a guest who wanted 4 tenths of the wedding cake. Could they get 4 tenths? It doesn't look like it. I only have these 3 tenths. I don't have 4 tenths. So my answer should be less than 1. This guest could not even get 4 tenths of the cake one time. He'd get less than he wanted. So I'm predicting our answer will be less than 1. But it's hard for me to think about what's going on here. I mean, I'm already confused. How can you take 4 tenths away from something that's less than 4 tenths? And in order to help us understand this, what we're going to do is a special magical trick. We're going to write this as a fraction. We're going to put the horse back in the bottom here. So there's our 4 tenths. And I'm going to put the cowgirl or cowboy right back up on top. And I am going to use something I know about fractions to make this to be easier for me, right? What I'm going to do is I'm going to multiply this by 10 because that will take this decimal and move it over one place, making it a 4, making it larger by 1 place value. And I'll multiply the top number by 10. That will make it larger by 1 place value also. And now I'll end up with 3 and 5 tenths. Now, the important thing to remember is that these fractions are equivalent. They are the same. They have the same value, right? They have the same value. So what I'm going to do now is I'm going to come over here and I'm going to rewrite this problem as this fraction over here, 4. And this is going to be 3 and 5 tenths. Getting that decimal out of there makes it easier because I know my 4 times tables, right? This is just easier for me to solve. Even though 4 is still less than 3.5, I know my 4 times tables well enough that I can do this division problem, right? So, before we go any further, I want to just give you some way to help you remember this story. You remember the cowboy and the horse, yeah? Well, there's something funny about horses. I don't know that we ever told you this. Actually, we did. We talked about this. Hey, we talked about this. Horses have a bad habit, and that habit is pooping all over the place, right? I know it's gross, not something we should be talking about on YouTube or in math class, but they make a big mess, right? All over the yard. And when you have a division problem that has horse poo out here in the yard, you should remember you always need to clean it up. Clean it up. Get rid of that horse poo. Get rid of that horse poo, and you will be a happier person, right? And that's what we did over here in this division problem, right? We had some horse poo, but we cleaned it up. We cleaned it up by multiplying that number by 10 and then multiplying that number by 10. We cleaned up the horse poo, so it's not out in the yard anymore. You might say, hey, yo, but it's still in the house. That's even worse, isn't it? No, it's not. You know why? Because houses have this incredible tool called a toilet. And you can flush it away. It's okay to have poo in the house. In fact, I hope you do poo in the house and not outside. Please tell me you don't go outside. All right, in the house is okay. Outside in the yard, not okay. Decimals outside, not okay. All right, let's go ahead and continue. Let's just get on with it here. So let's see here. How many groups of 4 can I take out of 3? And the answer is 0. And then that's okay. I will just go on to 35. How many groups of 4 can I take out of 35? And the answer is 8. 8 times 4 is 32. I subtract and I get a 3. Oh no, a remainder. I'm working with decimals, so I'll just pull the curtain back. How many times can I take 4 out of 30? The answer is 7. 7 times 4 is 28. This seems like a drag. There's still another remainder of 2. I'll have to pull the curtain back and show another place value. How many times can I take 4 out of 20? The answer is 5. Extend this out. 5 times 4 is 20, and hey, I'm done. Now that wasn't so bad, but you might still be wondering, so what's the answer to this problem up here? Well, remember that these two are both equivalent. They have the same value. So the answer to this problem is the same. 875 thousandths. Because remember, they're equivalent. Boom. All right, so cleaning up that horse poo. All right, stick with me. We're going to just do one more real quick, right? There's a lot of storytelling and silliness in that problem. Let's just take a look at this one right over here, and we'll go real fast. All right, first thing I notice, there's horse poo in the yard. I've got to move it 2 places, so that means I'm going to multiply by 100. You don't need to write that there. I'm just making it so you can see it. I want to move that horse poo over 2 places. I'm also going to move this horse poo over 2 places, right? If I multiply the horse by 100, I need to multiply this number by 100. Boom, there's the decimal. I'll remember to flush right away. Right? I'm going to extend this out. Flush, there's my decimal. What on earth would go here? Well, that's now the ones place, so I'm going to fill it in. We don't have anything in the ones place, so I'll fill it in with a 0. All right, now I have to be careful. In fact, sometimes I just like to rewrite this, right? Let me rewrite this as 25, no horse poop, thank you very much. And this is 750. And I want to avoid jumping to conclusions. A lot of people are going to say, hey, the answer is 3, I got it. Remember, use your place values, right? So how many times can 25 come out of 7? The answer is none. How many times can 25 come out of 75? The answer is 3. And here people are saying, see, I told you it's 3, but we're not done yet. 3 times 25 is 75. And there is nothing left. But what goes in the ones place? What goes in the ones place? The answer is nothing. So your real answer is 30. 30. And the answer to this problem up here is 30. Okay? So get rid of that horse poo, flush anything that's in the house, and divide like a pro. All right. See you later.